Good morning, everyone. So I'm going to talk about why we have selected CockroachDB in Kindred platform and the reason behind that selection, so that you find some useful information about CockroachDB and think about your use case and where you can be benefited from this solution, basically. So, bit of myself. I have been with Kindred Group since 2011 and in over different roles. And I have over 12 years of experience building different system, large scale and design and building system over the time of 12 years. Where we come from, bit of history of Kindred. Kindred was founded in 1997 by Anders Stom. He's our founder. And initial idea was find a better way of experiencing gambling. 2016, we become Kindred Group from Unibet Group. Our purpose is to transform gambling to ensure fair play, best deal, and great experience for our players. This is our purpose. These are some numbers from financial year 2018. Gross win revenue is 900 million plus million. EBITDA is 200 million. We have 25 million registered customer. 1.5 million active customer per day. So customer who logged in, place a bet, play games and all these things, around 1.5 million customers. Daily transaction 2018 was 31 million, but this year is 45 million plus transaction we are handling. From our main revenue comes from mobile, so it's 74% revenue comes from mobile. We have around 1,500 employees from 32 nationalities, so it's a very diverse company with many different nationalities working together. We have around 11 brands, so these are our brands: Unibet, 38, Maria Casino, Roxy Place, and iGame. All are our brand, serving geographically across the whole world. We operate these gambling products like sportsbook, live betting, racing, casino games, poker, bingo. All we run in our site and operate them. These are our global presence, where we operate mainly in the EU and Australia. We are also expanding to US from this year, so there will be more presence in US than today in coming days. So Kindred is basically a data-driven business. Data plays a very critical role in our business to offer best customer experience, and in terms of how quickly they can place bet, how quickly they can get a result, how quickly they can get a recommendation. All this stuff are driven by data and of course underlying the infrastructure. But there are data challenges at Kindred. One thing is disruption, disaster resilience. You probably know about RPO and RTO. RPO and RTO are the two key metrics that a organization should consider when creating a disaster recovery plan to maintain the business continuity after an unexpected error or incident happen. RPO is recovery point objective and RTO is recovery time objective. So recovery point objective is the measurement of the amount of data, maximum tolerable data loss you can afford after a major incident happen. So this is quite useful to define that how often you should actually take the backup. This is one of the key metrics you should be using. And in RTO is basically is a measurement to calculate that how quickly you should bring back your IT infrastructure and services to serve your customer, to ensure the business continuity, all these things. So we do have disaster resiliency plan today, but we are aiming to have state-of-art DR plan with very low RPO and RTO. That's our aim. It's very low, near to zero in this scenario. We also have like local regulatory compliance requirements. So you probably know about GDPR and all these regulatory requirements. We have to address these things because complying is a must-have requirement, and we cannot run business without being compliant. So this is also another important criteria we need to fulfill without much operational burden and in a very cost-effective way, basically. There is also another thing is to improve customer experience, like latency. How to reduce the latency between customers send a request and get a response. So that's also another important things we need to take into consideration. There are some other challenges as well. Protecting the invariants under high concurrent workloads and correlated failures and system upgrades, because protecting invariants like customer has a unique username, customer balance, we cannot invent money, and customer balance should not go below negative when pressing the when something happened wrong in the data center level. We also have like scalability challenges as well, sustained performance under peak load over large distance and flaky networks, fault tolerance, ensuring forward progress also during isolated and correlated disruption or failures, and complexity and cost. So all these things needs to be fulfilled, taken into consideration that we don't burn too much money on these things in terms of OPEX cost. So that's also another important criteria to fulfill. We have run some POCs with different database system, taking into consideration all these challenges we have, and we come to conclusion to select this product database system, CockroachDB. CockroachDB is a distributed SQL database. It has a standard SQL interface. It is ACID compliant, and it can tie data to a location, and on failure, data is efficiently distributed and replicated across nodes within the cluster. And one thing to note here, the isolation level. Isolation level is tricky when you think about ACID. ACID, atomicity, all these database parameter, durability and consistency and isolation level. Isolation level is very, very tricky one. And most of the cases, if you ask DBA or developer, they will be talking about like it is a read committed isolation level. And when you say read committed isolation level, it means that there is a possibility to have phantom reads and non-repeatable reads in this scenario. CockroachDB offers like serializable isolation level, which is like a highest level isolation level, and having a highest level isolation level in a distributed SQL database is a very tough things to fulfill, to be honest with you, and it does quite efficiently. So here I'll be talking about like why CockroachDB, we have selected the CockroachDB in our platform. When you think about like disaster and disruption resiliency, first approach how to handle these things come to most of our mind is like failover approach. Failover in the failover approach, what happens is that you have a primary data center that is doing all the processing, all the work, and you have a standby data center, and your critical system state gets replicated to the standby data center synchronously or asynchronously, right? And when you have a short disruption in primary data center, what happens here is that your processing gets delayed and your front-end services becomes unavailable, right? But when this disruption gets longer period of time, you need to resume your systems from the standby data center at some arbitrary time or recovery point of time, right? And that's where things get tricky. Like there is an issue that you may face like data consistency issue. You may face possible loss of data when you initiate the failover process. And there are other issue with the failover approach. One thing is like you actually pass down the failover, recovery, and backup, all these things to the application tier, and your application developer actually handle these things. So instead of spending time on writing code that will give the business value, they will be spending time on this recovery process, all these things. So that's valuable time is being gone into that sort of like fixing the disruption, basically. The other issue is that in the failover approach, you have to keep, it comes with the excessive cost because the associated like standby data center with the same level of capacity you need to keep like primary data center. So if you have a primary data center with 50% excess resources, you have to have a standby data center with a similar capacity, gives you overall like 300% overall resources footprint at a steady state. And that comes with a quite expensive cost if you think about the market you have to cover in your business. The third part is that failover approach is very tough to automate and test. You may see different issue when you initiate the failover process, and you may have missed these things in your testing process, and that may create some issue when you initiate the failover. So we have this process. We know the challenges in that approach. What we want is that to switch to multi-active deployment. So in the multi-active deployment, what happens is that you run your system, your multi-active system runs in multiple data center, and it can handle data center level outage or degraded capacity of at any scale transparently. And it is very different than the traditional failover active-passive, active-active approach, rely on the standby resources, and also multi-active system can actually serve the request simultaneously from multiple data center without relying on the customer locality, without any assumption on the customer locality, traffic affinity, or replication delay. So these are the beautiful part of the multi-active system. CockroachDB is a multi-active system. CockroachDB can run from multiple data center. It has the ability to handle data center level outage or any kind of disruption transparently. And it is horizontally scalable. So if you add an additional node to the existing cluster, it actually rebalances the data transparently without any human intervention. So that's a beautiful part of this one. The other thing is like it is a cloud native system, which means that you are not tied to yourself to a vendor, cloud provided vendor lock-in approach basically here. So that also enables other thing here is that you actually getting data portability as a byproduct. When I said that data portability as a byproduct, it is actually doing continuous replication across multiple data center and multiple cloud vendor. So you can easily switch to different cloud vendor, taking advantage where it makes sense. So continuous replication is built in this product, and it is automatically rebalance the data if you add a node or if you remove a node. So that's quite helpful. So this is one of the reason to select or most important reason to select CockroachDB in Kindred platform, because it survives the loss of the data center without service disruption or interruption. The next point is that geo partitioning in CockroachDB. So you may be familiar with the data localization or data residency law. which is very much in focus nowadays. This law requires a nation data of a nation citizen be collected, processed, and or stored in a country or a region. And GDPR has put much more emphasis on the data flow and the storage requirement. In fact, you cannot move out EU data out of the EU without customer consent. So that's a very critical legal obligation you need to fulfill if you want to run a business in EU. This is quite important to fulfill. CockroachDB has a feature called Geo Partitioning. What does mean is that you can actually tie a piece of data with a location. So I can say that this data should not leave Dutch or Netherlands boundary. I can put a node there and either tie the data with the geographical location, and data will be sitting there and will not leave the boundary of the country. So by default, Cockroach actually Cockroach can tie a specific table to a specific geographical location or a specific node, basically, to be honest with you. But with these geo-partitioning features, you actually have the row-level replication control. So you actually, what you are doing here is that you are controlling the row-level replication by tying the data with a geolocation. And this is handled natively by database system. So it means that my application developer or application tier is not actually dealing with this kind of like low-level details. So they are actually fully focusing on the business side without thinking about like where my data is flowing and how it is flowing. So this is really important for us. With these features, we can actually fulfill one obligation under GDPR, that tying data to a location, and data should not flow out of EU jurisdiction. Other important benefit we get from this geo-partitioning is that we actually can move the data close to user. So we can say that, okay, this user is in Australia, move this data to the Australia data center, which means that they don't have to pay the cost of intercontinental round trip in request response flow. So that actually improves latency quite significantly that we have observed. So these features actually enables to move the data close to our user where they are based, and we can serve the customers in a very neat way, basically, with these features. The last one here is the CDC or the change data capture. CockroachDB is a very good, excellent system of records, but we do need data from the database system in our analytical platform to do other analytical related work, right? Generating recommendation or personalization, or get a 360 view of the customers, that what he is doing in our website, because database is the source of the truth in our case. The database is the source of the truth. But how to get the source of the truth from database to analytical platform in a very good way is to use what we found is use CDC, change data capture. So change data capture is a process of extracting database changes in a real-time fashion and expose in some form to the analytical or some external system. So any write happens into the database, and that write could be update, insert, delete, and all these things. It even gets emitted to an external system from CockroachDB. And the benefit of doing this is that we are actually getting out of our traditional ETL approach of continuous pulling the database to get the changes. So we are automating the E part, which is the extract part, through change data capture mechanism, and our load part also automated with the sync connector. We use sync connector to load the data in S3 or some other external system. So E and L part is fully automated. What happens is that our developer fully focus on the transform part or T part, where the business value comes most of the time. basically. E and L part is basically infrastructure related, pulling or dumping data somewhere should be automated, basically. So in CockroachDB, it has a feature called change feed, and when you create a change feed, it actually emits the changes whenever write happens to database to a sync. And that sync can be Kafka or can be any cloud storage system, for example, S3 or Google GCP object storage system, you can do these things. So it is quite helpful to make data easy, to be honest with you. We don't have to do extra sort of like pooling or database, PL SQL code and all these things in our new platform. The other thing is like, it does not require a additional license like Oracle. If you are using Oracle, to enable the CDC, you need a Golden Gate license, additional license. This is not the case in this scenario. It is the same license you can use to enable the CDC. And these are other value adds. Some of like native scale out, distributed databases, multi-active ability that I already mentioned. Operational simplicity. The admin UI is a beautiful part of another beautiful part of CockroachDB. You can have much more understanding of how this cluster is database system is running just looking into like admin UI. Deployment flexibility, and it actually has the Postgres wire protocol. So you actually not learning a new API to talk to database. So you can use standard SQL, standard query or to talk to this database. And there is other one like follow the workload. So workload can be moved adaptively where the request comes from. So that's another beautiful part of these things. So that's pretty much it. Thank you for listening. So if you have any question, I can answer. Otherwise, I'll be here. So feel free to come. Thank you. Thank you.